Hello everyone, this is the task 2 of the Sparks Foundation internship, and the title of this task is Prediction Using Unsupervised Machine Learning. So, my name is Rashid and I am a data science intern, data science and business analytics intern at the Sparks Foundation. So, in this project involves using the Irish dataset, and I left a link here for those of you that need the data. So what the purpose of this project is to create an unsupervised learning model that will be trained on the data, that will be able to group the Irish dataset into clusters, and the clusters will be visualized. So we imported some libraries such as pandas. Pandas will be used for creating data frame. We imported NumPy. I imported matplotlib and Seaborn, which should be used for visualization. I imported KMeans, which should be used for the clustering. I imported TSNE that will be used to group the data into just to make the data two-dimensional. Then trade test plates, StandardScaler, and many others. So what I did here was to read the data into raw data variable. So, and then I check the head. This function will just print out the first five rows, and this will just bring out the info like the number of rows, the types, and many other things. So looking at the first data, we saw that we were given the species, and this species acts as a label, which will introduce linkage in our data, which is not needed. So we are going to drop this species and use the remaining 5 values. Then we are going to use this ID as the index. So looking at the info, we found out that none of the data has missing values, that all the data are complete. Then they are also in the right type, and we have 150 entries, that is 150 rows. So the first thing I did was to split the data into test and train sets, because we will train the data on the train set, and we will use the test set to evaluate how the data will perform on new data, how the model will perform on new data. So what I did was to create the train set, and to create the train set I had to drop the species, but it was not lost. Then I stored the train species in train label. Then the next thing I did was to use ID as the index using .setIndex from pandas. Then under the exploratory data analysis, the first thing I did was to check the statistics of the data, and the purpose of this is to know if there are outliers in the data. And looking at this, the minimum of sepal length is 4 and the maximum is 7.9. The 50th percentile, which is the median, is 5.8. So looking at this, you can see that each of these numerical values are in reasonable range. So we can't just say that they are outliers in data, because they are within reasonable range. So the next thing I did was to check the relationship of the variables. So since all our data are numerical variables, the best thing I could do is to use pair plot, so I can visualize all the data at once. So using pair plot, if you use a pair plot by default and without specifying any argument like I did, it's going to create a grid plot for you, and on the diagonal of that grid plot is going to put histogram there, and it's going to create an histogram of each of the numerical variables, and of the diagonals is going to create scatter plots. And looking at these diagonals now, so each value on the diagonal represents the histogram of the numerical variable. So looking at sepal length, you can see that sepal length is approximately normally distributed. Sepal width is also approximately normally distributed. So each of them are approximately normally distributed, but this one is looking like a uniform distribution. But we can see that there are no outliers in data, so we can't touch them. And looking at the scatter plot, you can see that sepal length against sepal width is kind of positively correlated, even though it is moderately positively correlated. Then sepal length against beta length is highly positively correlated, as you can see. and sepal length against petal width is also moderately positively correlated. Then checking petal length against petal width, it is highly positively correlated. And looking at each of these data, we can see that almost all the data are clustered. They are already clustered even without doing the clustering. They are already clustered into two. You can see that this is separated into two different plots. This one is also separated into two, but this one is looking like three. This one is also separated into two, and almost all of them are separated into two even without performing any clustering or creating any model on it. So it looks like 2 might be a great value for clustering, but we are going to check that out before creating the model. So the next thing I'm going to do is that from this visualization and exploratory data analysis, I found out that most of the data are moderately normally distributed. Then petal length and petal width are highly positively correlated. That means that what high petal length is associated with what high petal width. So the next thing is that what, judging from the Pearce grid scatter plot, most of the scatter plots have 2 or 3 clusters, that is, they are clustered into 2 or 3. Then since the data are highly correlated, it will be correlated using what, PCA. And for we to get a model that will have high accuracy, we have to standardize the data using StandardScaler, because the way KMeans works is that it gives importance to the feature based on their variance. So data with high variance is going to get high feature importance, and since all our data they are not in the same scale, this will mislead the model. So to get a good model, we have to standardize the data using StandardScaler, which will make all data have a mean of 0 and a variance of 1. So during another preprocessing stage, we are going to use StandardScaler and PCA, but since this step will be repeated for both the train set and the test set, it's better to create a pipeline that will contain these preprocessing steps, and it will perform that step both on the train set and the test set. So we use pipeline from sci-kit learn. So the first step in the pipeline is to scale the data using StandardScaler, and the second step is to decolorate the data using PCA. So we fitted the preprocessing pipeline on the train set. So before we can create our unsupervised learning model, we have to find the best cluster. Like, you have to find the best cluster for the data, and this is done using inertial in KMeans, which make our work very easy. In KMeans works in a way that for it to get the best model, what it actually does is to reduce the inertia. So what the inertia is like the centroid of the data. So it reduces the inertia of each of the data. So we are going to use a range of 1 to 7, that is, it contains from 1 to 6. That means the cluster, our for loop is going to test out each of the cluster, then we'll get the inertia of each of these values. So the perfect cluster is going to be that in which the inertia stop reducing drastically. And looking at this, we created the plot. Looking at this, at inertial of 1, the change from inertial of 1 to 2 is very huge. Like, the inertial of 1 is 500 and the inertial of 2 is 200, like almost 300 difference. Then the next thing is to check the inertial of 2. Looking at the inertial of 2, from 2 to 3 is also very huge. The difference is high. So you can see that 2 is not going to be a good cluster after all. So the next one I'm going to check is to check 3. And you can see that from 3, the inertial stopped, like the change in the inertial is not very high. So 3 would be a good choice for us. So now, since we already have our cluster number to be 3, so we are going to fit our model. So under fitting the model, we are using KMeans, and to fit the model, that is creating the model, is very easy using sci-kit learn. So all you have to do is to do model.fit and put the input data into this place. So then to see how the model will give to see the label that the model will give to each of the feature, we are going to use model.predict. So this is going to give us the label of the train set. But fortunately for us, we can actually test how accurate our model is, because in our data we are given species, which is the actual label of the data. So now we can test how accurate our model is. So we are going to create a data frame that is going to contain the predicted label, which is label pred, and the actual label, which is what, species. Then this label.head will give us the first five rows. Okay, now checking how accurate our model is, we can see that our model is very good, because the actual label of data is also 3 in number. So we also have 3 labels, so we can clap for ourselves at that junction. So checking how accurate our model is, we can see that our model was able to predict irate setosa very accurately, 37, and it had no error in irate setosa. But in terms of what, irate versicolor, it had 32, it predicted 32 correctly, and it was wrong in terms of 11. Then in terms of what, the third label, which is what, iris virginica, it had 28, it predicted 28 very well. And looking at this data, our model, if you calculate this accuracy, our model had over 80% accuracy, so it's not too bad. So now let's check how the model perform on new data. So testing this model on the test set, we found out that it predicted the first label correctly without having any error. Then the second label had just 3 errors, and the third label does not have any error. So we are very we should be proud of ourselves. This is a very good model. So the next thing is what, we are going to visualize the cluster. So since we have 4 features, it is going to be very difficult to visualize all these features on a scatter plot, since scatter plot takes just two, it's 2-dimensional. But luckily for us, there's a very powerful transformer in sci-kit that can help us turn our data into 2-dimension. So training this TSNE, or fitting this TSNE on the train set, it has turned it to 2-dimensional. So now we can visualize it. So visualizing our data, we found out that what, these are the three clusters that our data have. So we can see that there are 3 scalars, there are 3 clusters. Looking at this now, there are 3 clusters. This looks like 2, so 2 might also be a good cluster, but let's go with 3. Since the label of the actual label has 3 clusters, so we are going to go with 3. But this TSNE, the x-axis and the y-axis has no meaning in TSNE, so it is a little bit difficult for us to interpret. So we are going to visualize it using some of the original variables that we have, of initial features that we have. But looking at this, on the 4 features that we have, we still have 3 clusters, so that's very good. So the next thing we are going to do is to train the data is to check the clusters using separ length and peta length. So checking this now, you can see that we still have 3 clear clusters. So the first cluster is when this is supposed to be separ length. The first cluster is when separ length is very low, and peta length is also very low. And the second cluster is formed around here when separ length is low, and peta length is also like average. And the third cluster is when separ length is very high and also peta length is very high. So that is all we have for this project. Thank you very much.